The moon, Earth's only natural satellite, has fascinated humanity for millennia. From ancient myths and legends to modern scientific exploration, the moon has been a source of wonder, curiosity, and inspiration. Understanding the moon involves delving into its formation, physical characteristics, impact on Earth, historical significance, and the role it plays in modern scientific endeavors. Formation of the moon. The most widely accepted theory about the moon's formation is the giant impact hypothesis. According to this theory, about 4.5 billion years ago, a Mars-sized protoplanet called Theia collided with the early Earth. The impact was so colossal that it ejected vast amounts of debris into space. Over time, this debris coalesced and formed the moon. This theory is supported by the composition of moon rocks brought back by astronauts, which show that the moon and Earth share many chemical similarities, particularly in their isotopic compositions. Despite this, the exact details of the moon's formation are still debated, and alternative theories, such as the double planet hypothesis, where the Earth and moon formed together, or the capture hypothesis, where the moon was captured by Earth's gravity, have been proposed. However, none of these alternatives offer a better explanation than the giant impact hypothesis, which remains the leading model for lunar formation. Physical characteristics. The moon is a barren, rocky world with a diameter of about 3,474 kilometers, 2,159 miles, making it roughly 1/4 the size of Earth. It is the fifth largest moon in the solar system, though it is relatively large compared to Earth. The moon's surface is covered in regolith, a layer of dust and small fragments of rock created by billions of years of meteorite impacts. These impacts have also left the moon heavily cratered, as there is no atmosphere to protect it from incoming space debris or to erode its surface. The moon has two main types of terrain: highlands and maria. The highlands are bright, heavily cratered areas that are geologically older. The maria, Latin for seas, are vast, dark, and flat plains formed by ancient volcanic eruptions. These smooth, basaltic plains make up about 16% of the lunar surface and were originally mistaken by early astronomers for large bodies of water. Gravity on the moon is only about 1/6 that of Earth's, meaning objects weigh significantly less. This lower gravity, coupled with the moon's lack of atmosphere, results in some unique physical phenomena, such as the ability of dust to stay suspended longer when kicked up and the moon's sky being perpetually black even during daytime. One of the most distinctive features of the moon is its synchronous rotation with Earth, meaning the same side of the moon always faces us. This phenomenon occurs because the moon's rotational period is the same as its orbital period around Earth, a process called tidal locking. As a result, one hemisphere, known as the near side, is visible from Earth, while the far side remained a mystery until the space age. The moon's role in the Earth-Moon system. The moon's gravitational influence on Earth is profound, affecting not only the tides but also the stability of Earth's rotation. Tidal forces, caused by the moon's gravitational pull, result in the rise and fall of sea levels. These tides have a wide range of impacts, including influencing marine life and the Earth's climate over long periods. The moon also stabilizes Earth's axial tilt, which is responsible for the planet's seasons. Without the moon, Earth's tilt could vary significantly over time, leading to dramatic changes in climate and potentially making the planet less hospitable to life. Over time, the moon has been moving slowly away from Earth. Currently, it recedes at a rate of about 3.8 centimeters per year. This gradual drift will, over millions of years, alter the dynamics of the Earth-Moon system, affecting the length of days and the nature of tides. Cultural and historical significance. For millennia, the moon has played an important role in human culture, religion, and mythology. Ancient civilizations often associated the moon with gods and goddesses. For example, in Greek mythology, Selene was the goddess of the moon, while in Roman mythology, Luna held the same title. Many early calendars were based on the lunar cycle, with months being approximately one lunar cycle long. The moon has also been a symbol of change and transformation. Its waxing and waning phases have been linked to cycles of life, death, and rebirth. In many cultures, the moon is considered a feminine symbol, often representing intuition, emotion, and fertility. Scientific exploration of the moon. The dawn of the space age in the mid-20th century marked a new era of exploration and understanding of the moon. The space race between the United States and the Soviet Union was largely driven by the goal of lunar exploration. The Soviet Union's Luna 2 became the first human-made object to reach the moon in 1959, followed by the first successful landing of an unmanned spacecraft by Luna 9 in 1966. However, it was the United States Apollo program that truly captured the world's attention. On July 20, 1969, Apollo 11 successfully landed humans on the moon for the first time. Astronaut Neil Armstrong became the first person to walk on the lunar surface, famously declaring, "That's one small step for man, one giant leap for mankind." Over the course of 6 Apollo missions between 1969 and 1972, a total of 12 astronauts explored the lunar surface, collecting rock samples, conducting experiments, and leaving scientific instruments that continued to send data back to Earth for years. One of the significant discoveries of these missions was that the moon was geologically inactive. There are no active volcanoes, and seismic activity or moonquakes is relatively minor compared to Earth. This lack of activity means that the moon has changed very little over the past billion years, offering scientists a preserved glimpse into the early solar system. While manned lunar exploration ceased after the Apollo program, interest in the moon has never waned. In recent years, both government space agencies and private companies have set their sights on returning to the moon. NASA's Artemis program aims to land humans on the moon again by the mid-2020s, with the long-term goal of establishing a sustainable human presence and using the moon as a stepping stone for future missions to Mars. China's space agency has also made significant strides in lunar exploration, particularly with its Chang'e program. In 2019, Chang'e 4 became the first spacecraft to successfully land on the far side of the moon, marking a major milestone in space exploration. The moon's resources and future exploration. One of the reasons for renewed interest in the moon is its potential as a source of valuable resources. The lunar surface contains vast amounts of helium-3, a rare isotope that could be used in future nuclear fusion reactors, providing a potentially limitless source of clean energy. Additionally, the moon's regolith contains water ice, particularly in permanently shadowed craters at the poles. This water could be a crucial resource for future lunar colonies, as it can be used for drinking, growing food, and splitting into hydrogen and oxygen for rocket fuel. The moon's low gravity and lack of atmosphere also make it an ideal location for scientific observatories. Telescopes on the moon's far side would be shielded from the radio noise generated by Earth, providing a pristine environment for studying deep space. Other countries than USA are also ramping up their lunar ambitions. China has made significant advances with its Chang'e program, including landing on the far side of the moon and bringing back lunar samples. India, Japan, Russia, and private companies like SpaceX and Blue Origin are all planning missions to the moon in the coming decades. In conclusion, the moon has always been a source of fascination and inspiration for humanity. From ancient myths to modern scientific endeavors, it has played a central role in our understanding of the cosmos. As technology advances and humanity looks toward the future, the moon will likely continue to be a stepping stone for deeper space exploration and a vital part of our quest to understand the universe. Its resources and strategic importance make it a key target for both scientific study and the future of space travel.